we're on. I think it's the third page in your note packet. Okay, when we talk about an ellipse, there's going to be some parts to an ellipse that we've never really talked about before. And every ellipse is going to have what we call two focus points. Okay, and those two focus points are something that we will find on all the ellipses that we find. And sometimes we use those focus points to find out what the equation is and things like that. It also has some other key parts that we're going to talk about down here. But basically what makes an ellipse different than a circle is that we have these two focus points. And if I were to, when we talk about the plural of those, we call them the foci, kind of like a cactus is cacti, and these are foci because we have two of them. If I were to add the two distances together, so if I picked any point on this ellipse, this is a point they picked out right here. If I add the distance from this focus to here, and then the distance from this focus point to here, and if I added those two together, it would be the same no matter what point I picked. If I picked a point all the way over here, and I connected two segments to that point, and I added those two together, it's going to be the same sum no matter what. Okay, so anywhere on that ellipse, I could pick a point out, and the distance to the two focus points would be the same, and that's what makes it different. Now, what's different about this than a circle is that circle, we always go to the radius and it's the same all the way around. These two distances are not the same. They could be the same, but they typically are not going to be the same. So we would, and we're usually not going to find what this distance is, but at least that's what a focus is. And just so you kind of know what we're talking about when we talk about what a focus is. So we're going to talk about some of the major parts of an ellipse. We have what we call the major axis. And so when we have an ellipse, the major axis is going to be the longer axis. And so you're going to have a longer axis one way and then a shorter axis the other way. If I turned the ellipse, kind of like this guy is down here, then the longer axis would be up and down and the shorter axis would be left and right. So it's either going to be longer vertically or it's going to be longer horizontally. And that's why sometimes we call it a horizontal ellipse, sometimes we'll call it a vertical ellipse. So the major axis is the longer axis of symmetry. And then the minor axis is the shorter axis of symmetry. The center is where those two axes intersect one another. There's going to be a point right in the middle, as you can see down here. These two axes intersect in the middle of that ellipse. That would be the center of the ellipse, just like we would think it would be. The vertices are the endpoints of the major axis. The covertices are the endpoints of the minor axis. So there's 4 points essentially that we're going to be looking for that would land on that ellipse, and it's kind of where it reaches its extension point. So like here, these would be my 2 endpoints on the major axis. These would be the 2 endpoints on the minor axis, and it would be different if it was a vertical ellipse. But we're going to basically have 4 points on the outer part of that ellipse that we have to identify. So if we come down here and kind of label some of these and talk about some of the values that we're going to use here. So first up, this right here would be a vertex point. This right here would be my other vertex point, and I'm just going to label it with V. This right here is what we call a co-vertex. And on this one is my other covertex. I'm just going to label it CV for covertex. So we have two vertice points, we have two covertex points. The point right here in the middle is my center. And then the 2 points on the inside of that ellipse are called the foci points. And the two foci points are always going to land on the major axis. They'll always be on the bigger axis, not the shorter axis. Okay. Same thing goes over here. The only difference on this one, these would be my two vertex points. These would be my covertex points. This is still my center. And because this is longer vertically than it is horizontally, these would be my two focus points, and they're still on the longer axis in both cases. So those would be our two focus points. Okay, so just kind of labeling it very, very similar, just one's longer horizontally than vertically. Okay, we're going to use some variables to represent how far away this is from the center. A vertex point is always the same distance from the center. And so we call that plus or minus A. So for instance, if this was at positive 5, this would be at negative 5. So they're always the same distance away from the center, wherever that center is at. In this case, if we said the center is 0, 0, it would be 5, 0, negative 5, 0. But our center is not always going to be a 0, 0. We'll find that out later. Okay, same thing for the covertices. The covertices are always the same distance away from the center, but we call this our B value. So B units up and B units down. And that would be our covertice. And we always use B for the covertices. Over here, this would be my A value, this would be my B value, because this is the longer axis, this is the shorter axis. So that's the one thing that changes on the vertical ellipse is you still have an A value and a B value, but now my A value is vertical and my B value is horizontal. So they just flip-flop it. The length of the major axis is always 2A, okay? And we'll talk about the numbers here and how it makes sense. But like I use this example here, if I go 5 to the right and 5 to the left, then the total length of that axis would be 10, 2 times 5, right? So it's always 2 times whatever that A value is. And the same thing for the minor axis. It's going to be 2 times whatever the B value is. Okay, the foci, we said, are always going to be on the major axis. And the variable that we used for that one is C, plus or minus C units away. C to the right, C to the left. Or if it's vertical, we'd go C up and C down. Okay, now this formula here is going to be a big deal. C squared equals A squared minus B squared. It kind of looks like the Pythagorean theorem, but this is not the Pythagorean theorem. Really, the only difference is we're doing A squared minus B squared equals C squared, whereas the Pythagorean theorem is always A squared plus B squared equals C squared. So make sure it's really, really close, okay? That's why a lot of people get those two confused. And all you have to do is make sure it's a minus sign, not a plus sign in between. And that's the formula we're going to use a lot. Because what's going to happen on a lot of these is it may ask us to find the foci. So if I know A squared and B squared, then I can use those two to find the foci. Or eventually what we'll do is I'll give you the foci and maybe the vertices, and we'll use those two to find the missing part. So we'll be given 2 out of the 3, and we have to use those two to find the third. Okay. Standard form of a ellipse. Now there's 4 different equations here. They're all very, very similar to one another, just based on if it's vertical or horizontal, what kind of ellipse do I have. If my center is at 0, 0, it's going to look like this. And that would be for a horizontal ellipse. If we have a vertical ellipse, the only thing that is different is the a squared and b squared will flip-flop. But the one thing is it would always equal 1. And then that's where it's going to differ a little bit from the circle formula. We have fractions over here, obviously, and it's always going to be equal to 1. And I'll show you how we can get it equal to 1 if it's not already there. That would be if your center is at 0, 0. If you have a center that's different than 0, 0, it'll be kind of like what we did with the circle. Okay, the circle, we said we had the h and k value. So it's exactly the same equation I had up here, except we had to add the new center and the h and the k value. And that looks very similar to what we did with a circle. This equation is going to be exactly the same, except we're going to plug in h and k again. Oops. A squared should be over here. Sorry about that. B squared should be here, and still equals 1. Okay, so those are our 4 different types of ellipse equations, all very, very similar to one another. The things that we're going to have to pay attention to is where's my center at? That's going to be a really big part of it. Okay, if there is a center at 0, 0, it's going to be one of these two. If my center is at somewhere else, I'm going to use one of these two. And then is it a vertical ellipse or is it a horizontal ellipse? And that'll tell me where the a squared and b squared values go. Okay, so a lot of information. It'll come a little bit easier once we start seeing some examples of these. I know I'm throwing a lot of different stuff at you there when we do that. A lot of stuff we haven't seen before. All right, let's start with number 1 here. Okay, this is why I kind of like this packet, is it kind of lays everything out. It has a piece of graph paper on it. A lot better than trying to do all this on a piece of notebook paper. Okay, so we are given this equation, okay, and we want to decide all of these things, and then we're going to graph our ellipse. We got to find the center, vertices, co-vertices, and then the foci to finish up. The first thing I always want to decide is what kind of ellipse is this going to be? Is it going to be longer horizontally or is it going to be longer vertically? Well, if the bigger number is underneath y, then it's going to be longer vertically. Okay? If the 36 was here and the 4 was here, then it's going to be longer horizontally. So it's all based on what variable is it underneath. And that's where you can use your x and y's to kind of think about this. Okay? So the first thing, and I always kind of like to write this, is I know that this is a vertical ellipse. It's going to be longer vertically than it will be horizontally. I usually like to write that at the beginning. There are no numbers attached to the x and the y, so that tells me my center is at 0, 0. Life's pretty good if our center is at 0, 0. Okay, the bigger value will always be our a squared value. So in this case, 36 is the bigger value. So I'm going to do a squared equals 36. So a is going to be plus or minus 6. Which means my b squared value is 4. So b is plus or minus 2. Okay, what that tells me is, because this is a vertical ellipse, it's going to go up and down 6 units. So my x value is not going to change. My y value is going to go up 6 and down 6. You can write it as 2 separate ordered pairs, which we will sometimes probably, but in this case I think this is the easiest way to write it. Just know that it's 2 separate ordered pairs, 0, 6 and 0, negative 6 if we separated them. And then my co-vertices are going to move left and right, and so it would be plus or minus 2, 0. Okay, I'm going to finish out with the foci here at the very last, but I'm going to go ahead and start graphing this just so we can kind of start to see the graph here a little bit. So we're going to go up 6. We're going to go down 6. We're going to go right 2. We're going to go left 2. And we're going to make our ellipse. Okay, if you wanted to, you could put your center in the middle at 0, 0. The last thing that we're going to do is we're going to find the foci. Okay, and the foci, once again, the formula is c squared equals a squared minus b squared. You're always going to put the big number first, okay? Because we're not going to take the square root of a negative because that would give me an imaginary number. And we're not going to end up with imaginary numbers here. So the easiest way to remember it here is biggest number, a squared is always going to come first. So that gives me c squared equals 32. So my c is, I would say, approximately plus or minus 5.66, 5.7, whatever you wanted to round to. And that would be my foci. And it's going to be on the same axis as my major axis, which is my moving up or down my y-axis in this case. Okay, now, we said the foci should always end up inside of the ellipse. My vertices went up 6 and down 6, so this is just barely inside of it, okay? But it's still inside. It's really, really close to it. And so when you graph your foci here, it's almost to the edge, but not all the way. It's like they pretty much run into one another when our graph is this small, okay? And we just know it has to be on the inside. It has to be smaller than this number here. If I get a number here bigger than this, then something's wrong. Your foci will never end up outside your ellipse. But a lot of times it'll be right up close to it, very close to the end of that. That also tells you that it can't be on this axis because that would be outside the ellipse. Okay, that's our first ellipse. Any questions on that first one? Lots of different things that we got to find there. All right, let's do number 2. What's the one big difference about number 2? It's horizontal, you bet. Okay, this is going to be a horizontal ellipse because the bigger number is underneath the x squared, the smaller number is underneath the y squared. Okay, so in this case, my a squared value is 64, which means a is plus or minus 8. My b squared value is 25, which means b is plus or minus 5. We don't have any numbers attached to x and y, so we're just going to say our centers is 0, 0. This time, my vertices are going to move left and right because it's a horizontal ellipse. It's my x value. So we're going to move right 8 and left 8. So my vertices would be positive 8 and negative 8 at 0. My co-vertices are going to move up and down. So that would be 0 plus or minus 5. And at that point is when I usually graph it. So we got our center. And that would be our ellipse. And then the last thing that we finish up with is 64 minus 25, which is 39. Bless you. C is plus or minus 6.2, 6.24, whatever you want to round to. And so we would say plus or minus 6.2 and 0. You could also leave it as a radical, but as for graphing purposes, it would be better to probably do a decimal here. Okay, this one's a little bit closer, or not quite to the edge. It's a little bit further to the inside, so it's a little bit easier to see the foci there. And those would be our two foci points. Okay, so very similar to number 1, except it's longer horizontally than it is vertically. Okay, number 3. On number 3, we have a different center, okay? And this is just like the circle. It's always the opposite of what my signs are going to be. So if this is x plus 1, this would be left 1. If this is y minus 2, it would be up 2, okay? And so we would say that our center here is negative 1, 2. And that's what makes it a little bit more difficult here, because we're not starting at 0, 0. If we start at 0, 0, it makes things a little bit easier. So the first thing we're going to do is we're going to go left 1, we're going to go up 2, and that's our center. That's where the ellipse will be centered at, not a 0, 0 anymore. My a squared value is 49, which gives me a is plus or minus 7. My b squared value is 9, so b is plus or minus 3. Okay, is this one going to be longer horizontally or vertically? Horizontally, right? Because the bigger number, 49, is underneath the x. So it's going to be longer left and right than it will be up and down. Now here's what we have to do to find our vertices. That's why 0, 0 was so easy, because I could just add it to 0, right? When I add 7 and subtract 7 here, I have to do it to the x value. So negative 1 plus 7 would be 6, 2. Negative 1 minus 7 would be negative 8, 2. So we're going to move 7 to the right. We're going to move 7 to the left of our original x value, because I have an a value of 7. And make sure you add it and subtract it to the x value. If it was longer vertically, we would do it to the y value. So that means my co-vertices are going to add to the y value of my center, and we're going to go up 3 and down 3. So 2 plus 3 would be 5. 2 minus 3 would be negative 1. Okay, and we're going to plot those 4 points. Or what you could even do here is you could just count 7 over from here. Okay, 1, 2, 3, 4, 5, 6, 7. And I could go 7 the other way. And then I could go up 3. And I could go down 3. So you could plot them and then come up with the ordered pairs. I came up with the ordered pairs first, just to make sure that those are where the points are at. It kind of is up to you. I think it's easier just to count, to come up where those points are going to be at. Then you don't really have to do a whole lot of math involved with it. Okay, and then the last thing here is our foci. So we're going to go 49 minus 9, which is 40. Okay, and so C is about 6.3. We said our original A value was 7, so this is just a little bit less than 7. When I write this for my foci, I think the easiest way to do this is this. We're adding it to the x value. So we're going to go negative 1 plus or minus 6.3, and we're not doing anything to the 2. I think this is the easiest way to write this. And you could probably do the same thing here, but because we're dealing with whole numbers, I think that's a little bit easier to write them out separately so we can get our points. Here, since we're dealing with the decimal, I think it's easiest just to rewrite it like that. So we're going to add 6.3 to the left and to the right, which all that means is we're going to go 6.3 to the right. We're going to go 6.3 to the left. We're just barely inside of the two vertices, and those would be our two foci. Okay, so a little bit harder when the center's not a 0, 0, because you got to make sure that you count from that center, not 0, 0. That's probably another common mistake, is trying to count from 0, 0, because that's what we're used to doing when we graph points. But here we got a new center. Okay, questions on that one? Okay, I'm going to skip over number 4. Okay, number 5. Okay, this one, is it going to be horizontal or is it going to be vertical? It's going to be vertical, right? The bigger number, 36, is underneath the y value. So that tells me it's going to be longer vertically than horizontally. Okay, my center. Opposite, right? So this is positive 4, positive 2, so that's going to make negative 4, negative 2 for my center. Okay, vertices. A squared is 36, the bigger number. So A is plus or minus 6. B squared is 20. So this is a little bit different because this is the first time we haven't seen a perfect square for A squared or B squared. And that's okay. Sometimes that's going to happen. So the square root of 20 would be about 4.5 or 4.47, whatever you round to. Okay, so vertices. We're going to count up and down. And if you wanted to write it as plus or minus 6, you could. But because we're dealing with whole numbers here, I'm going to leave this number alone. And we're going to add 6 to it, which puts me at positive 4. And then negative 2 minus 6 will be negative 4, negative 8. If you plot those two vertices, you're just going to go up 6 and down 6. Make sure you do it vertically, though, since it's longer vertically. Okay, my co-vertices, and this is where it gets a little bit tricky because we have a decimal here. And anytime we have a decimal, I probably would prefer to write it like this. Negative 4 plus or minus 4.47. And then, bless you, and then leave the y value alone here. So leave the negative 2 alone. And we're just going to add 4.47 to negative 4, and we're going to subtract. If you want to write two separate ordered pairs, you can. Typically, if it's integers, I write two separate ordered pairs because that's easier. If it's a decimal, I'll just write it as a single ordered pair with the plus or minus in it. Okay, that's just kind of the rule that I usually use because of the decimals. Okay, so what makes that a little bit tricky here is from the center, we're going to go about 4.5 to the right and 4.5 to the left. And we're just going to kind of estimate somewhere between 4 and 5. There would be our ellipse. And then for the foci, the good thing here about the foci is that c squared is 16, so c is plus or minus 4. So our foci are going to go up 4 and down 4. So if I'm at -4, -2, if I go up 4, I would be at +2. And if I go down 4, I'd be -4, -6. Hello? Okay, with your stuff or? Okay, all right, sounds good. Go to the office. She said you might bring your stuff with you. Okay, put those 2 points on as our foci, and there's our ellipse. All right, number 6. Number 6 looks different. Whenever we have an ellipse equation, we always want it to equal 1, right? Every equation that we've done up to this point, we've always had equals 1. Over here, we've always had fractions, right? And so that's what's different on this one, is we don't have fractions and it's not equal to 1. Well, what could we do to make this equation equal to 1? What could I do to 144 to make it 1? Divide, yeah. We're just going to divide by itself, right? But if I divide this by 144, I got to divide everything by 144. Okay, so that gives me an equation of x squared over and what we're going to do here is we're going to simplify 9 over 144. And really we're saying how many times does 9 go into 144? And typically we're going to give you numbers that work out pretty nice here. So how many times would 9 go into 144? 144 divided by 9. 16. Okay. And then the nice thing here is 16 over 144 would be 9. Okay. So those two are going to be my two bottoms. So all we did was just reduce, and now we have the equation that we want. Okay. And really from here it's pretty easy because we have a center. Where's my center going to be at? 0, 0, right? That's good news. My a squared value here is 16. So a is plus or minus 4. My b squared value is 9. So b is plus or minus 3. Okay, this would be a horizontal ellipse because the bigger number is underneath the x. So that means plus or minus 4 and 0. You can write it as two separate order pairs once again, 4, 0, negative 4, 0, but especially from 0, 0, I just like to write it like that. My co-vertices would be 0 and plus or minus 3. So we're going to go 4, 0, negative 4, 0, up 3, down 3. There's our ellipse. And then to finish this one out, c squared equals 16 minus 9. So we would get plus or minus 2.65. And that's going to be on our x-axis. Be right there. All right, we're going to do one more today. Okay, number 7. And this is where we kind of put everything together. And it's kind of like some of the ones we did yesterday. It's kind of like some of the ones that we did with circles, is we're going to have to complete the square, okay? And we're going to have to, when I see x squareds, y squareds, and when I see a -9 here, we think, oh, well, I'm going to divide by -9. But when I see an extra x right here that's not squared, then that tells me we're going to complete the square. And I only have an x here, not a y, that I have to complete the square with. This one down here, and we might start the day off tomorrow with doing this one. I don't think we'll have time to do both of these today. But on number 8 has both an x and a y in it, okay? So the first thing that I would do here is x squared minus 10x plus something plus 4y squared equals -9. And we're going to complete the square like we've done before. We're going to take the middle number. We're going to divide by 2 and get -5, and -5 squared would be 25. -9 plus 25. Okay, we're going to factor it. So over here, I would have x minus 5 squared plus 4y squared equals 16. We're almost there, okay? We still want this to equal 1. It's not equal to 1 yet, okay? Before we start graphing it and before we start doing anything else, I always want it to equal 1. So kind of like we did on the last one, we're going to divide by 16, but you got to make sure you divide everything by 16. So this would be x minus 5 squared over 16, because there's no coefficient out in front, so there's nothing to simplify with it. The 4 over 16 becomes what? Y squared over 4 equals 1. Okay, is this going to be longer vertically or horizontally? Horizontal. Okay, bigger numbers underneath the x. So we know this is horizontal. My center, we have a number attached to the x but nothing to the y, so this is going to be positive 5, 0. A squared is 16, so A is going to be plus or minus 4. B squared is 4, so B is going to be plus or minus 2. We're going to add 4 and subtract 4. From my center, and we're going horizontally, so we're going to subtract 4 from 5 and add 4 to 5. My co-vertices, we're going to go up 2 and down 2 from the center, so we're going to go 5, 2, and 5, negative 2. Okay, for my foci is going to be 16 minus 4, which is 12, so C is about 3.5. And that would be my foci. Okay, to graph it all, we got 5, 0 is my center. And then we're going to go right 4. We're going to go left 4, up 2, down 2, and then my foci would just be barely inside of that. All right. Homework for today. One, 2, 3, 4, 6, and 7. And this is on homework 2, the second page of your homework packet. Okay, those 6 problems.